In this video I'm going to be looking at the solution to question 5 of the June 2010 Edexcel M1 paper. The topic of the question is kinematics. The question starts by describing a situation where we have two cars P and Q moving along the same stretch of horizontal road. Car P is moving at constant speed 25 meters per second. And at time 0, P overtakes Q, which is moving at a speed of 20 meters per second. It says from t equals some time capital T that we have to find in the question, P decelerates uniformly, coming to rest at a point x, which is 800 meters from the point where the overtaking took place. From a time t equals 25 seconds, Q decelerates and comes to rest at exactly the same point of x and at the same instant as P. In the first part then of the question, we're asked to sketch all of that information onto a speed-time graph showing where they both come to rest at point x. Having done that, we need to find the value of t. Well, the graph then that we need to find, or we need to sketch, looks as follows. So taking car P first of all, it's initially going at some speed 25 meters per second and then slows down from this point at a constant deceleration. The car Q is going slower than that, but travels the same distance at the end of exactly the same time. So the graph must continue for a longer period of time before starting to slow down. Now, putting some numbers onto here, the car P was initially going at 25 meters per second, so this is speed in meters per second, and started to slow down at some time t that we need to find. And finally comes the rest at this value here, which was t that we need to find. Car Q, on the other hand, travelled for 25 seconds at this constant speed and then started to slow down. So this was time here along here in seconds. Seconds. The marking for this part of the question, there were 4 marks. They're all B marks, so no method marks. The B1 was given for the general shape of these lines or this graph. A B mark for realizing that they must that Q must continue longer before it starts to slow down, and that the graphs must cross over in this fashion. A B mark for showing them finishing at exactly the same time, and then a B mark as long as all of these labels were on the graph correctly. So 4 marks in total. The second part of the question uses the fact that the total distance travelled by both cars was 800 meters. So the total distance travelled is equal to the area under each graph. So first of all, using the graph for Q, where we know that it goes for 25 seconds to start off with. So what we're trying to do here is to calculate the time little t. So the area under the graph 800 is equal to 1/2 the sum of the opposite sides. So this was 25 plus t, and multiplied by the distance between those parallel sides, which was the speed the q was travelling at initially, 20. If you rearrange that, then t turns out to be 55 seconds. The fact that that's way out of proportion for our graph doesn't matter. We didn't actually know what t was going to turn out to be until this point, so it doesn't matter that t would, this little t here would be a lot further away from the origin had we drawn our graphs to scale. Now doing a similar thing for p, so that was for q, now for p, exactly the same distance travelled, 800, but this time we've got parallel sides to our trapezium of capital T, and now we know that the other side is 55, and this is multiplied by 25. If you then evaluate this one, you get that t turns out to be 9 seconds. That evaluation comes from multiplying through by 2, 1600 is equal to 25 times t, and then plus 1375. Then subtracting and dividing by 25 gives you the value of t. The marking for this part of the question, then 8 marks in total available. There's a method mark and accuracy mark for getting this equation correct to start with, and then as long as that equation was correct, a method mark, so what's called a dependent method mark, or DM1, and an answer mark for the value 55. M1 and A1 for the equation for P, and then again DM1, and finally an A1 for the value of capital T equal to 9. So in total there are 8 marks. Well, that concludes the solution to this question. Solutions to other questions can be found at www.furthermaths.org.uk.